So today we are going to discuss about AI techniques. So the technique or the topic is very important. So today we'll be exploring various techniques and why they are needed and how they are applied in real world. That's what we're going to discuss. So are the objectives of AI technique are capture the knowledge from data, solve real world problems, improve decision making, automate tasks, enhance efficiency and accuracy. So, first, what is capturing the knowledge from data? So, AI systems learn from experience. So, just like a child observing the environment or the world, AI systems learn from whatever they observe. Okay, so what we understand here is we have to deal with large amount of data. So the ability to extract meaningful knowledge from the raw data is the very first objective. Secondly, to solve real world problems. So AI is not just theoretical concept, it is actively being used to solve real world problems, from practicing or from predicting diseases to detecting frauds in banking. So we will see some of the examples. Third one is improving or decision making. So traditional softwares use rules, right? So AI, on the other hand, can evaluate multiple possibilities and just suggest the best decision based on the available information. Let us take an example. See, we are using Google Maps in our day to day life. So it helps you to find the best route, the fastest route. So that's where the AI comes in taking the decision. Fourth one is automated tasks. So sometimes repetitive and time consuming tasks can be done, uh, can be done or by AI systems in an efficient way so that the effort of the human is reduced and the error is also reduced. For example, tasks like sorting emails, scanning documents, or monitoring factory machines are all automated using AI. The last one is enhance efficiency and accuracy. When AI is properly designed and trained, it performs better tasks faster and more accurately rather than humans. Especially in areas like image analysis, language translation, and numerical predictions, this plays a very, very important role. So, these are the five core objectives that guide our understanding of AI techniques. So, we will see one by one. Okay, now let us talk about the foundation. See, what exactly is AI? AI deals with solving very large or complex problems. Okay, it is one of the field of computer science that focuses on building machines capable of performing tasks that normally requires human beings, human intelligence. So, for example, let us take the field how AI is used in healthcare, finance, and transport. For example, suppose you wanted to teach a machine to recognize the human face. So, the face, for example, in different lighting situations and different angles, it is it is different, right? So, without beard, without glasses. So, there are no simple rules you can write to code all these things or to consider all these things. So this is where AI helps us. Okay. So it helps us in multiple fields. So some of the examples I've shown here. For example, if you take in healthcare, it helps to predict the diseases like cancer or any kind of image. So for in finance, in banking systems, it helps to find the fraudulence. In transportation, it helps in managing the traffic, etc. So, this session will help you understand the techniques that make all these things possible. So, what is the scope of AI? Okay, how wide it is being reached. So, how many areas it actually covers? So, AI covers wide range of applications. We mean genuinely across almost field of the human activity. It is used in healthcare, finance, education, handle problems from simple to complex. So that's what we discussed in the last slide. Okay, so AI is capable of handling problems that range from simple to highly complex problems. Simple application might be filtering the spams in emails. A complex one may be dealing something with the MRI images or X-ray images to identify some kind of disease. So there is a lot of scope how AI is evolving around our day-to-day life. Okay, so these are the building powers or building blocks that is being used all around in all the applications. Now we'll talk about the types of problems. What kind of problem does AI actually solve? We are saying it's used everywhere, but what kind of problem actually it solves? So generally when we say the first one is the daily practical problems. So these are the problems that we encounter in our daily life even after realizing there is AI is involved. We use Google Maps, okay, for navigation. So these use AI to give you the right result at the right time. Suppose if you're traveling from A to B, then it gives you the fastest or the shortest path. It tells you where is the traffic, what is the other route you can take. These are the practical cases where AI is used in our day-to-day life. Second one is identification problem. Okay, for example, it's used in face recognition and biometrics. Okay, so you are using smartphone. Your smartphone, for example, uses unlocking with your face, your eyes, your thumb, etc. So even in your workplace, you have your face recognition system as your biometric. So these are all used as an where the identification problem is used. Third one is the authentication problem. So security systems, OTP verification, and voice authentication. So these are authentication problems. So AI verifies who you are before granting access. So this is used in critical sectors like banking and in cyber security. Fourth one is classification problem. So spam detection is a perfect example. So AI classify an email as a spam or not spam. So image classification is another. Okay. So given a photo, AI classifies whether it is a cat or a dog or a car or a person. So this is being, majoritarily it is being used and in various research purpose, these images are dealt with. Fifth one is cross-domain problems. So this is a very, very exciting one, where AI combines with other fields to solve complex challenges. So AI combined with healthcare to predict patients' readmission, AI combined with agriculture to detect crop diseases from drone images. So it is not limited to one type of problem, it's versatile. So always it works across the disciplines very well. Now we will talk about the nature of the AI problems. So understanding the nature of AI problem helps us appreciate why AI techniques are needed in the first place. So the problems might be complex, dynamic or interconnected. So when I say complex, these involve many variables, many possible outcomes and many uncertainties. So when it is dynamic, the environment keeps changing in real time. When it is saying interconnected, one problem often connects to another. So, for example, in healthcare, a diagnosis is connected to the treatment, which connects to the drug availability. So, there will be a connection between the problems. And For all these things, is there a fixed solution? So, no fixed solution in many cases. So, we say in maths like 3 plus 3 is 6, but these kind of real time problems does not have a fixed solution. So, requires continuous learning and adaptation. And all these problems, these real time problems involving uncertainties, cannot be solved using traditional methods. So that is why we are in need of dedicated AI techniques for specific problems. Next, we'll discuss about the importance of data. So, I mean, when we talk about data, AI completely relies heavily on the data. So, data is the fuel of AI. Without data, AI cannot function. So when I say data, so what is this data? So data can be structured in two major types. One is structured and another is unstructured. Structured data is nothing but something that is organized, formatted data like spreadsheets, databases, tables. So these kind of data are easy to process. While when we talk about the unstructured data, so, like text, images, audios, videos, so most of the data in the world is unstructured. So, processing this requires sophisticated AI techniques. So, a large volume of data improves the accuracy, learning capability. When I say accuracy, the more examples an AI system sees, the better it learns, or it learns the pattern out of it. So, when I say learning capability, so, when it learns more, when there are more data available, AI generalizes better. So, handling new situations. And data may come from multiple sources, like we don't rely on a particular source. It might be from a sensor, from a database, from the internet, from the user. So, integrating all these things and bringing out the or generalizing something with a solution is always unique. Next, we will discuss about data processing in AI. Having data is one thing, but processing the data is where the real work happens. Raw data is never ready for AI directly, so it needs to go through several steps. Step one is data cleaning. What do you mean by data cleaning? So, the real world data contains lot of errors, missing values, and duplicates. So, it's messy, like a garbage. So, if you read the data directly, AI will take bad decisions. So, second step will be to transform. After cleaning, what happens is, after cleaning, what happens exactly? So, data needs to be converted into a format that AI algorithms can work with. So, this might involve converting text into numbers, for example, scaling values or normalizing the ranges. So this is the data transformation. Third one is data classification. Here, similar data is grouped together, separating medical images of tumors from non-tumors, for example. Fourth step is the knowledge extraction. This is the most important step. Finding useful patterns in the processed data. This is where AI shifts from just storing data to actually understanding it. So, these four steps form the core data pipeline in any AI systems. Next, we'll talk about the dynamic nature of the data. So, this is one of the most challenging aspects of working data with AI because data is always not static, it changes over time. If you train a model on a traffic data set, and I mean, suppose for an earlier data set like it available on 2020, and if you're using it today, the predictions will be poor because the pattern changes every day, and nowadays it has been completely changed. New roads are built, your population has grown up, and then your work from home culture has been increased after COVID, the traffic signaling process has been changed, and how are all these going to uh, affect your predictions? Okay, so the most major examples, as I told you, one was a traffic pattern and weather condition. So nowadays you cannot at all predict the weather, right? So it's very important that the data or the dynamic nature of the data plays an important role. So that is why model retraining, online learning, continuous data pipelines are some of the aspects of real world AI deployment. Next, we'll be talking about the challenges in data handling. Suppose we are having a see, when I have to do some predictions or deal with data, that data volume is going to be very large. So every second, enormous amount of data are generated from various sources like social media, sensors, satellites, and transactions. So the sheer volume is overwhelming. So, difficulty in identifying which is relevant and which is irrelevant. So, not all data is useful for us. So, separating relevant from irrelevant is again a very big process. Sometimes your data might have noises, it might have outliers. So, when I say noises, it refers to random errors in your data set. Outliers are the data points drastically different from the rest of the data that you're having. So, outliers might try to mislead the predictions and limited availability of useful data. In um, some areas, some parts where the availability of data is very limited, we not have useful data. So, there might be a lot of outliers and noises itself. So these challenges, makes us think how this data science and data engineering use the data to predict the results. Next, we'll discuss about knowledge building. So what does knowledge building says here? It talks about AI knowledge can be built from data and experience. It uses previous information and learning algorithms to make decision making and predictions. So, when I say AI builds knowledge from the data, the AI system processes thousands of examples and begins to identify the patterns. So, it's not going to memorize each example, it generalizes from them. Second one is how it is going to learn from the experience. So with each prediction it makes, it checks whether it was right or wrong and adjusts itself accordingly. So it uses previous information such as a doctor draws on years of the patient cases as AI system draws on its training data. Then learning algorithms, very important. So mathematical engines like decision trees, neural networks, and support vector machines power this learning process. So the goal of all this is to enable decision making, which is the best one, and enable the predictions. So knowledge is what separates an intelligent system from a simple lookup table. Now we will discuss about the types of AI problems. So, the first one is the structured problems. Clearly define the rules and constraints available. For example, best example would be the chess. You know, the rules are already fixed and there is no ambiguity on it. The second one is the unstructured problems. You don't have clear rules like your structure. So, example, Natural language understanding is the best example. So you have to understand idioms, context, emotions, so there are no fixed rules for that. Third one is the linear problems. So it's predictable and proportional relationships. So regression models can handle these well. The last one is the non-linear problems. So complex, unpredictable relations are involved in this. For example, neural networks are specifically designed to handle them. So understanding which category a problem falls into helps you to choose the right AI technique. Next, we'll talk about the real world impact. Like, what is the real world impact? Like, how it improves the productivity? Like, AI systems work 24 cross 7, how much it reduces the human effort. So repetitive tasks are handled by AI so that AI, I mean, the human can be more creative and do a lot of strategic calculations. Then enables automation. Entire workflows can be automated from customer service to chatbots to quality control and manufacturing. So where these are specifically used in smart cities, it manages traffic signals, it monitors air quality, energy optimization and consumption. Robotics is used in where in warehouses, surgeries, and in disaster management. A lot of recommendation systems are there, like we use Amazon, Spotify, Netflix. So all these are some of the real world impact where we can see AI is really used. Next, we'll discuss about some of the core content. Okay, now we will talk about how AI is used. I mean, the core concepts I want to really talk about. The main techniques are the searching techniques, how the knowledge is used, and about the abstraction. So, when I talk about the search, so what is a search? Search provides a way of solving problems for which no more direct approach is available, as well as the framework into which any direct techniques can be embedded. So, when we don't know the exact answer to a problem, and there is no formula to directly compute it. So, then we have to use the search to explore all possible solutions until we find the one that works for the given problem. Suppose imagine we are navigating a maze. Okay, so you'll try to find one path. It might lead to a dead end, so you might backtrack, get another path. So this is how your search works, algorithm works. A search algorithm tries to find a solution and uses various sequences of actions or operators until you find a solution. So operators are the moves that you take. The search algorithm tries different combinations until you find a goal. So some of the famous search algorithms are breadth first search, depth first search, A star algorithm, which uses heuristics, and then Minimax algorithm, which is used in game playing. Okay, so some of the advantages when you talk about these AI. So it is the best way so far, as no better way has been found to solve all the problems. Like we have a lot of gaming problems, we have a lot of real world problems. So, to solve a problem using a search, it is only necessary to code the operator that can be used. The search will find the sequence of actions that will provide the desired result. Very, very important. So, you don't need to write the exact solution. You have to define the starting state, the goal state, and what are the possible moves allowed. Then the search algorithm will help you to find out the path. So when I talk about the disadvantage, most problem have search space that is very very large. So you cannot go and search the whole space to find a solution. So when you take an example of chess alone, the number of possible game positions exceeds the number of atoms in the observable units. That is why we need something called as intelligent search. Okay. Now, we will talk about the second major AI technique, that is the use of knowledge. The use of knowledge provides a way of solving complicated problems by manipulating the structure of objects that are concerned. Instead of blindly searching, if we have a domain knowledge, then we can use to solve the problems more efficiently. Think about a doctor diagnosing a patient, for example. They don't try every possible diagnosis, right? They use your medical knowledge to narrow down and try to diagnose the disease. Okay. So this is called as the use of knowledge in action. Okay. So first one is when I talk about the knowledge representation, first one is knowledge captures generalization. So what do you mean by knowledge? I'm talking here. Like I'm talking about here. Knowledge capture generalization. So what it tries to do here is group similar situations together instead of storing each one separately. So shared properties is equal to one representation, not many. So saves memory and reduces the need for constant updates. Example, instead of storing sparrow files, eagle files, parrot files, pigeon files separately, you can generalize it like bird, fly. So one rule replaces millions of facts. Okay. So if sometimes if something lacks the grouping property, so it is just the data. So second one is the what is the how it is represented and how it is understood by the people. So it should be represented in such a way that it can be understood by the people who prepare it. Example, domain experts, the lawyers, engineers, they are the one who are preparing the data. They must be able to understand it and verify it. If they're not able to do that, then it will be very, very difficult. Okay. Next one is easily adjustable. It could easily be adjusted to correct errors and to demonstrate the changes in the real world. Medical guidelines are updated, laws are amended. Good knowledge representation must allow easy updates without rebuilding the entire system. Next one is the overcoming the limitations through volume. So it can be used to overcome its own sheer volume by helping to restrict the range of possibilities that must usually be considered. So, well organized knowledge actually helps reduce the search space. The last one is the usable, this one, usable even if it is incomplete. So, it could be used in different situations even though it may not be complete. That's very, very important. So, a doctor doesn't always have all the test results. So, based on whatever they have, they try to do the diagnosis. Okay. Next, we'll talk about the abstraction, the third major AI technique. Abstraction finds a way of separating important features and notifications from the unimportant ones. So it's essentially the art of focusing on what matters and ignoring what doesn't. Example, when you want to look at a map to navigate from one place to another place, you don't need to know the color of every building or every name of the shop. You need the roads, the distances, and the landmarks. That's enough, right? So in AI, when the system recognizes a face, it doesn't process every pixel actually. It focuses on the key features like shape of your eyes, distance between the nose, lips. So the main features it focuses. So this is where the abstraction is very powerful. So it generally reduces the problem size, improves generalization, and makes AI more scalable. So, AI techniques is a method that exploits knowledge that should be represented in such a way that the knowledge captures generalization, it can be understood by the people, it can be modified to correct errors, it can be used in many great situations, even if it is not accurate, it can be used to overcome the bulk knowledge and can be narrowed down to whatever it is having. Okay, that's what we talked about. So that the knowledge captures generalization, meaning similar situations are grouped, understandable by the people, even when the data is collected automatically from readings, the knowledge must be readable, understandable by the people. And the knowledge of the data is always being supplied by the domain experts. So in many AI domains, people who understand the subjects are the one who supplies the knowledge to the program. And it is easily modifiable and be corrected from errors. So also we saw that it is usable even the data is the knowledge is incomplete or inaccurate, so that it reduces the complexity and it helps to narrow down the range of possibilities. So the famous example is the tic-tac-toe example. Simple game. Okay, so to understand the AI techniques, different approaches of playing tic-tac-toe are used. So generally a tic-tac-toe is a 3 cross 3 grid. Two players play with X or O. The goal is get three of your symbols in a row. That's very simple, right? Okay. So when you talk about the impact of AI technique here, AI picks any empty square, no knowledge of the player like a beginner. I mean, it does not require no knowledge, plays like a beginner. Okay. The AI searches for a winning move. It tries to maximize this. It blocks the opponent. So it uses generalizations. Okay. And the concept of abstraction is used. So as a program grows in complexity, generalization and clarity of the knowledge increases. So where the true AI technique is being used. So finally, I would like to conclude AI techniques handle complex and dynamic problems. Traditional programming handle only fixed and predictable problems. AI techniques are specifically designed for problems that are complex, changing, and interconnected. So, the data is a foundation of AI. So, without data, there is no learning. So, every AI technique begins with the data. So, it needs to clean, it needs to process and manage the data. Next one is continuous learning. So AI is not one time effort, it has to keeps on churning because the data is dynamic. So AI systems must continuously learn, adapt and update themselves. So AI plays a key role in the future technology. So it's going to be the heart. So to close, so these are the references I used from Stuart Russell and Peter Novick and then from Parag Kulkarni. Thank you.